This is Calc 1, section 1.1. Share the screen. First, let me show you the problems for those of you that don't have the book and aren't getting it. On page 19, there's the assignment, but I might change it from time to time. 1 and 2, 3 and 4, hopefully. So on the video in my demonstrations, I'll be going fairly quickly. Reason number one is so I can get the video smaller, so it's not so long. And the second reason is you can always rewind, fast forward, pause as much as you wish. So I'll be going fairly quickly in my lectures because of that. Much faster than if we were meeting face to face, let's say. Okay. So we should get a chance to see what the questions look like. Some more here. Here. And some more over here. Try to get this thing focused a little bit. There we go. Some more there. This machine tends to go out of focus on me sometimes. Some more there. Okay. Now we'll go over a lot of problems. So in my demonstrations lecture, I'll quite often just do a whole bunch of problems from the homework. Okay. Number one is simply a matter of, are these the same function or are they not? F of x is x plus radical 2 minus x. G of u is u plus radical 2 minus u. They are the same function. You're just changing letters there. So number one is a yes, they are the same function. Number two, are these exactly the same? Because if you do the algebra, you could factor the numerator into x times x minus 1 and then cancel out, and you get f of x equals x. Okay, so are these two exactly the same? They are not the same because g of 1 exists, but f of 1 does not exist. Okay, so you cannot plug in 1 here, but you are allowed to plug in 1 here. So no, they are not exactly equal. Okay. Okay, 3 and 4. I'll do 4 for you. State the values of which f of negative 4 and g of 3. So f of negative 4 in the red graph, 1, 2, 3, 4, that comes out to be negative 2. So this is negative 2. G of 3, blue graph, 3, 1, 2, 3, 4. So this looks like it's 4. Okay. For what values are f and g the same? That's where they touch. So the x values are negative 2 and 2, negative 2 and 2. See, estimate the solution of f of x equals negative 1, y equals negative 1, y equals negative 1 for the f graph. Looks like here and here, so that would be negative 3 and positive 4. So negative 3 and 4 it looks like. D, on one interval is f decreasing. So the graph of f is going down. I'm going down the roller coaster. Well, between 0 and 4. Okay, so this one would be between 0 and 4. Give the domain and range of f. Domain and range of f. So for the domain, looks like it's going from negative what? 1, 2, 3, negative 4 to 4 inclusive. Okay, so f has a domain of negative 4, 4 inclusive. And for the range, how low and how high does it go? From negative 2 up to 3 inclusive. From negative 2 to 3. Okay, state the domain and range of G. So G goes from here to here. That would be 1 to negative 4 to 3. So for G, domain is negative 4 to 3. And for the range, the lowest seems to be about here, which is a half. The highest is 1, 2, 3, 4. So I would say negative a half to 4 inclusive. Negative 1 half to 4. Okay. 7, 8, 9, and 10. Is it a function or is it not a function? You might recall the vertical line test. So 7 is not a function. 8 is a function. 9 is a function. 10 is not a function. Looks like it's climbing up by steps. Okay. So again, this is no, yes, yes, no. Okay. Domain and range. Okay. Only if it's a function. This one's pretty easy. 9's a little bit tricky because there's a break in the graph. So for 9, the domain, which I'll abbreviate with D again. So there's a closed circle here, so I'm counting that. So everything from here to here, that's negative 3 to 2. Negative 3, 2. Negative 3, 2, 1, 0. Right. Okay, range. Well, there's a break here. This is negative 3 to negative 2, counting negative 3, but not counting negative 2. So negative 3, 2, parenthesis, union, bracket from negative 1 up to here, which is 3. Okay, so the y values go from negative 3 to 2, not counting 2. Then it starts up again at negative 1 and goes up to 3, including negative 1 and negative 3. Okay, 13 and 15, you try on your own. 15, you're just reading the graph. The graph shows the power consumption for a day in September in San Francisco. What was the power consumption at 6 a.m.? Just read off here. So that would be 700 megawatts. 6 p.m., that's 1,800 hours. That's up here, that's 700. So I would say maybe 720. Right? When was the power consumption lowest? Well, maybe right here. So 4 a.m., which makes sense. I guess everyone's sleeping. And when was it the highest? So peak use is at 12 noon. Okay, everyone's awake by that time. Okay, next problems I want to look at. Next set of problems. 27 to 49. Those kind of problems. 29, f of x is 1 over x. They ask for f of x minus f of a divided by x minus a. F of x is 1 over x. F of a is 1 over a over x minus a. Clean it up by multiplying top and bottom by xa. Okay, so the bottom becomes x minus a times ax. 1 over x times xa becomes a. Negative 1 over a, xa becomes a minus x. This fraction comes out to be negative 1. So the final answer is negative 1 over xa. Okay, and a side note you might recall from algebra, anytime you have a minus b over b minus a, that's equal to negative 1. Okay, 31 asks for the domain of this function. So this will be undefined whenever the denominator is 0. So I set the denominator equal to 0, x squared minus 9. Set it equal to 0, that's x plus 3, x minus 3 equals 0. X is plus and minus 3. So plus and minus 3 get thrown out of my domain. So the domain is all real numbers minus a set consisting of negative 3 and 3. The braces means it's a set. Don't use parentheses, that already means something. Don't use brackets, that already means something. Use braces. So it's all reals, the funny looking R, minus a set consisting of negative 3 to 3. On a real number line, you're shading everything except for negative 3 and 3. 37. F of p equals radical 2 minus radical p. So there's a square root inside a square root. Well, first of all, just from here, this tells me p, this radical here, p has to be greater than or equal to 0. And at the same time, because of this radical, whatever is behind my finger, 2 minus radical p has to be greater than or equal to 0. Add radical p on both sides and square both sides. 4 is greater than or equal to p, or p is less than or equal to 4. So the domain is P is between 0 and 4 inclusive, so bracket 0, 4. In 41, they give me a piecewise defined function, so I break it up into pieces. I obey the root x plus 2 of x is less than 0, that's linear. Y-intercept of 2, slope of 1, but it's an open circle here because x is less than 0. Then x is greater than or is equal to 0, I obey the root 1 minus x, which has a b, y-intercept of 1, slope of -1. So that's what the graph looks like. And it asks me stuff like f of -3 is -1, f of 0 is 1, f of 2 is -1. Okay. All right, and then moving right along. Yeah, going way back. Yeah, I didn't write these in before earlier, so back to problem 4, if you want to see what the solutions are. F of -4 is -2, G of 3 is 4, B, the answers were -2, 2, C, the answers were -3 and 4, D, the interval 0, 4 in parentheses, E, the domain is -4, 4, the range is -2, 3, and F, the domain is -4, 3, the range is 1/2, 4. So this is sort of like the back of the book, if you would. Okay. Number 8 is a function. The domain is bracket -2, 2. The range is bracket -1, 2. Number 10 is not a function. Domain is bracket -3, 3. And range is bracket -3, 3 also. I'll show you quickly what those were. So this was number 8. Okay, domain is for x. Range is for y. Okay. And for 10, both x and y have domains -3 to 3. The step function, it's not a function, does not pass the vertical line test, but it looks like it's going from -3 to 3. Okay. Going back to 13, you put some ice cubes in a glass, fill the glass with cold water, and let the glass sit on a table. Describe how the temperature of the water changes as time passes. Then sketch a rough graph of the temperature of the water as a function of the elapsed time. So you've got ice inside a glass of water. So the temperature goes from room temperature goes down to 0 degrees C. And then as the ice melts, the water stays at 0 degrees C until it's all melted. And then it goes back up eventually to room temperature. So here's a rough sketch. Goes down to 0 degrees C, freezing point of water. While all the ice melts, it stays at 0. Then it goes back up and then it eventually equilibrates to room temperature. 45 asks for a graph of x plus absolute value of x. I made a little table. Plug in -3, you have -3 plus 3, which is 0. Plug in -2 plus 2 is 0. -1 plus 1 is 0. 0 gives me 0. 1 gives me 2, 2 gives me 4, 3 gives me 6. So it's almost like a piecewise defined function, where here it's y equals 2x, and here it's y equals 0. Okay, 53, x plus y minus 1 squared equals 0. Find an expression for the function whose graph is a given curve. So I subtract x, take the square root of both sides. Okay, since it wants the bottom half, I put a negative there. And I add 1 to both sides. So f of x is 1 minus the square root of -x. Okay, quick side note, you might think this is not possible. This is possible if x is a negative number. You cannot plug in a positive number, but you can plug in a negative number. 59 asks for an expression for the area of an equilateral triangle. So all the sides are S, 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 and I drew myself an altitude, which makes this half S. And I've got a little Pythagorean theorem going on here. Okay. So h squared plus half s squared is equal to s squared. H squared plus 1/4 s squared equals s squared. Subtract 1/4 s squared on both sides. H squared is 3/4 s squared. So H is the square root of this guy. That's s radical 3/4 or s radical 3/2. And the formula for the area of a triangle is 1/2 base times height. So 1/2 s times the height, which we now know to be s radical 3/2. Final answer, s squared radical 3/4. 61. An open rectangular box with a volume of 2 meters cubed has a square base. Express the surface area of the box as a function of the length of the side of the base. So since the bottom's a square, x, but this doesn't have to be the same, so we'll call it y. He said the volume was 2, so x squared y is 2. Divide by x squared, y equals 2 over x squared. And now for the surface area. Surface area, the area of the bottom is x squared. There's no top. The 4 faces all have area x times y. So x squared plus 4x y, and I replace y with 2 over x squared over here. So the area of x is x squared plus 8 over x. 4 times 2 is 8. X cancels one of these, but I still have one more on the bottom. Okay, then finally we have some questions about even and odd functions. Is a function even, odd, or neither? So you might recall for an even function, f of negative x is the same as f of x. Examples are x squared, x to the 4th, absolute value of x, cosine x. These are all even functions because if I plug in negative x, I get the same thing as the original x. Okay, a function is odd if f of negative x gives the opposite of f of x. Example is x cubed, x to the 5th. Sine x is odd. Tangent of x is also odd. Sine of negative x is the opposite of sine of x. Okay, one reason why it's called even and odd, as you can see by the exponents, x squared, 4th, 6, 8, 10 are even. X to the 3rd, 5, 7, and so on. Those are odd, but those aren't the only odd functions. Right, so technique is you plug in negative x. So for 74, here's the original f of x. If I replace f of x with negative x, I get negative x squared over negative x to the 4th plus 1. But negative x squared is the same as x squared. Negative x to the 4th is the same as x to the 4th plus 1. I get back the original function. So this is an even function. 76, however, f of x is x absolute value of x. If I replace x with negative x, I get negative x times absolute value of negative x. The absolute value of negative x is the same as absolute value of x. Okay, and how does this compare with the original? They're opposites. So in other words, f of negative x is the opposite of f of x. So by definition, I have an odd function. And finally, 78, f of x is 1 plus 3x cubed minus x to the 5th. F of negative x, I put a negative x there, negative x there. That gives me 1 plus 3 times negative x cubed, so negative 3x cubed. And then negative x to the 5th, that's going to be plus x to the 5th. Okay, is this the same as this? No. Is this the opposite of this? No, they're not quite opposites. That changed sign, but the 1 stays the same. So they're not opposites. So 78 is an even. So this was section 1.1.